guys, this video shows a reliable docking control scheme for probe-drogue refueling. Part 1. A brief introduction to the simulation system. A MATLAB Simulink-based simulation environment with 3D virtual reality display has been developed by our research lab to simulate the docking stage of probe-drogue area refueling. The developed simulation environment includes 5 main parts: the receiver model, the drogue model, the Sim2VR interface, the VR display, and the TILC controller. Next, the drogue model is focused. It contains 4 main parts: the ball wave effect, the tanker model, the HDU module, and the link-connected house drogue model. Next, the VR display is focused. The docking stage can be shown from the ground view, from the tanker view, from the receiver view, or some other views. Part 2. Docking simulation of probe-drogue area refueling. Simulation 1. Basic simulation. 3 docking attempts are carried out in the basic simulation. This is the first docking attempt. At the beginning, the receiver stays in the standby position. Then the receiver approaches to the drogue slowly. When the receiver is close to the drogue to some extent, the ball wave effect comes into play, and finally, the probe doesn't capture the drogue, so the first docking attempt fails. This is the second docking attempt. By learning from the last docking experience, the probe captures the drogue in the end, so the second docking attempt successes. This is the third docking attempt. By learning from the last docking experience, the probe captures the drogue with a smaller docking error than the second attempt, so the third docking attempt also successes. The iterative convergence speed is high, and a successful docking can be achieved at the second docking attempt. Simulation 2. Simulation with uncertainties and disturbances. The effect of the system uncertainty and disturbance is considered. First, add uncertainty to the actuators. Secondly, change the ball wave effect. Thirdly, add a side wind disturbance to the atmospheric environment. Besides, add the Dryden wind turbulence model to the PDR system. 3 docking attempts are also carried out in this simulation. This is the first docking attempt. At the beginning, the receiver stays in the standby position. Then the receiver approaches to the drogue slowly. When the receiver is close to the drogue to some extent, the ball wave effect comes into play, and finally the probe doesn't capture the drogue, so the first docking attempt fails. This is the second docking attempt. Because the existence of the uncertainties and disturbances, the probe doesn't capture the drogue, so the second docking attempt also fails. This is the third docking attempt. By learning from the last docking experience, the probe captures the drogue in the end. So the third docking attempt successes. When there exist the given system uncertainties and disturbances, the proposed TILC controller can still achieve successful docking at the third attempt. The convergence of the terminal docking error of the simulation is shown in this figure. The 2 simulations exhibit favorable results. TILOC is robust, and the proposed controller can also provide successful docking in the presence of the system uncertainties and disturbances. This makes the docking process safer and more reliable.